Hi everyone, in this video we are going to learn about compiler. And the main topics included in today's video are introduction to compiler, structure of a compiler and phases of a compiler. First we'll see what is a compiler. Compiler is a system software which converts a program written in high level language to low level language. In the previous videos, we have seen what is an assembler. Assembler is a system software which converts assembly language program into machine language program. So when we compare compiler with the assembler, the compiler requires more storage space and processing time than an assembler. And also the designing and writing a compiler is very complex. And here you can see the diagrammatic representation of a compiler. The input to the compiler is the source program written in high level language. Examples for high level languages are Java, C, C++, etc. And the compiler will convert the source program in high level language into low level language or machine language or object program. During the compilation, if there are any errors, the compiler will report all the errors. Now we are moving on to the structure of a compiler. As you can see in the first diagram, the compiler can be divided into two parts, analysis part and synthesis part. Analysis part is also calling as front end, whereas synthesis part is also calling as backend. Analysis part actually contains a set of phases. Synthesis part also contains a set of phases. The phases which are part of analysis stage are machine independent, but the phases which are part of the synthesis stage are machine dependent. Okay, so the source program will be given into the analysis part first, and the output of the analysis part will be an intermediate code representation of our source program. This intermediate code representation will be given as input to our synthesis part or stage. Then the synthesis stage will generate the corresponding, convert the intermediate code representation into an equivalent machine code. So actually analysis stage is machine independent, whereas synthesis stage is machine dependent. Now you can see the second diagram. Here I have included the phases which are part of the analysis as well as the synthesis stage. The phases which are included in the analysis phase are lexical analysis, syntax analysis and semantic analysis. Whereas intermediate code generation, code optimization and code generation are part of synthesis stage. So the source program will be given into the analysis stage and it will generate an intermediate code representation of our source program, and this intermediate code representation will be given as input to the synthesis phase. Then the synthesis phase will translate our intermediate code representation into the corresponding target machine code. This is the structure of the compiler. Now we are moving on to the basic functions or tasks of a compiler. In this system programming subject, mainly we are talking about the compiler in terms of its basic functions or tasks. So the main four basic functions or tasks of a compiler are recognize basic elements or tokens of source program, then recognize syntactic units and interpret their meaning, then storage allocation and code generation. So the first task of a compiler is recognizing basic elements or tokens of source program. That means the source program will be converted into a sequence of tokens or basic elements. Tokens are nothing but our variables, operators, constants, keywords, etc. Once we have converted our source program into a sequence of tokens, we have to check whether this sequence of tokens are in proper logical order or not according to the syntax of the source program. So that is the second main task of a compiler. Recognize syntactic units and interpret their meaning. Whatever string of tokens we have generated as an output of the first task, we have to check whether the tokens are in the proper logical order according to the syntax of the source program, and if it is in the correct order, again we need to check whether it has the proper meaning or not. After that, the main task of a compiler is storage allocation. Storage allocation is mainly contains the allocation of the variables used in the source program. What all variables we have used in the source program, we have to allocate storage space for those variables. That is storage allocation. Then the last main task of the compiler is code generation. Code generation means depending upon the target machine, we have to convert our source program into the machine code representation. That will be the fourth task, main task of the compiler, that is code generation. So these are the basic functions or 4 tasks of a compiler. Now we are moving on to the phases of a compiler. It is a very important topic. Okay, so here we know that I told you in the first slide, the compilation process is so complex. So the compilation process will be partitioned into different sub-processes which are called phases of a compiler. Okay, so here you can see on the right side an example for the 6 phases of a compiler. Okay, so in general, when we are talking about a compiler, it has mainly 6 phases: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. First, we will look into this example, then we will come to the main phases of the compiler. Okay, so here we have an example statement, that is position equal to initial plus rate star 60. It is a statement from our source program. Okay, so the first phase of the compiler is lexical analysis. Lexical analysis will convert this statement into a sequence of tokens. It is performing by an analyzer called lexical analyzer. So the lexical analyzer is also calling as scanner or token analyzer. So tokens are nothing but the basic elements of our source program. When you look into this particular source program statement, it contains 3 variables: position, initial, and rate are 3 variables, and it contains 3 operators: one assignment operators, one assignment operator, and 2 arithmetic operators. Then we have one constant. So the lexical analyzer will convert this particular statement into a string or a sequence of tokens like this. So what will be the output? Since it contains 3 variables also calling as identifiers. So the position will be named as first identifier ID1, initial variable is calling as ID2, rate will be mentioned as ID3. So output of the lexical analyzer will be like ID1 equal to ID2 plus ID3 star 60. So the source program statement has been converted into a sequence of tokens. And here it contains mainly the variables or the identifiers, operators and a constant. So this is the output of the lexical analyzer. Converts the source program into a sequence of tokens. This particular output will be given as input to the syntax analyzer. It will be given as input to the syntax analyzer. Syntax analyzer will check whether this sequence of tokens are in proper logical order or not according to the syntax or grammar of the source program. We know that each and every source program will be having a particular syntax or grammar. Whether this sequence of tokens are in proper order or not according to the syntax, that will be performing by the syntax analyzer. Syntax analyzer will generate errors if it is not in the proper sequence. Okay, so we know that grammar means what? It is containing set of rules, right? So the syntax analyzer will convert the output of the lexical analyzer, that is the stream or sequence of tokens, into a parse tree. It is an intermediate representation. So the output of the lexical analyzer, that is the sequence of tokens or a string of tokens, will be converted into a parse tree. If we are able to convert the particular source program statement, tokens statement, into a parse tree, then we can say that that particular token statement is in a correct order according to the syntax of the source program. If you are not able to create the parse tree successfully, then which means the particular string of tokens are not in a proper order. Okay, so when we talk about a parse tree, the root node or each node will be representing each parent node will be representing the operator, and the child nodes will be representing the operands of that particular operator. So this is the corresponding parse tree for this particular statement. So the syntax analyzer will receive the output of the lexical analyzer, that is a string of tokens, and along with that it will take the grammar or rules of the particular source program and it will generate a parse tree. If you are able to create a parse tree, then that particular statement is syntax free. Otherwise there are some syntax errors. Okay, then we are moving on to the, so syntax analyzer is also calling as parser. Okay, then we will come into the third stage or the third phase, that is the semantic analyzer. Semantic means meaning. Okay, so after checking the syntax of the particular tokens or the string of tokens or a sequence of tokens, it will check the meaning of that stream of tokens. Okay, so example, suppose I have a statement A equal to B divided by C. Actually it is syntactically correct, A equal to B divided by C. But if C is equal to 0, which means what? Semantically the meaning will not be correct. That means A equal to B divided by C is syntactically correct, but semantically it is not correct. Okay, so the semantic analyzer will check the meaning of the particular output of the syntax analyzer. Okay, so here, suppose here we have an example. In this, as I told you, we have three variables: position, initial and rate. Suppose these identifiers are of type float, but the 60 is of type integer. In order to perform the particular arithmetic operation, we need 60 also in float format, right? So the semantic analyzer will automatically typecast 60 into of type float in this third phase. Okay, so that we can easily perform this id1 equal to id2 plus id3 star 60. Okay, so the semantic analyzer will check the meaning of the string of tokens. Okay, so that is the third stage. If we want to do any typecasting, it will be automatically performing by the semantic analyzer. So till this stage, it is part of our analysis stage. At the analysis stage is also calling as front end, and this lexical analysis, syntax analysis and semantic analysis phases are machine independent. What is the main task of these phases? Divide the string into different tokens and check whether they are in proper order or not according to the syntax of the source program, and check the meaning of the program statement. So these three statements are, or these three phases are machine independent. Okay, now after that, the output of the semantic analyzer will be given as input to the intermediate code generator. Intermediate code generator means the entire program will represent in an intermediate form. Okay, that means I told you till this stages it is machine independent. So before converting directly into the target machine code, it will create a intermediate code representation after the semantic analysis. The most commonly using intermediate form is the 3-address form. Okay, 3-address form or 3-address code. 3-address code is nothing but there will be, for each statement there will be an operator, and for each operator there will be two source operands, source operand 1 and source operand 2, and it will be containing a target operand to which we are storing our result. Okay, so each and every statement in our source program will be converted into an intermediate code representation. Most commonly using intermediate code representation is the 3-address code. 3-address code is nothing but it contains a single operator, and for that operator there will be two source operands, source operand 1 and source operand 2, and the target operand. Okay, so this particular statement we have converted into 3-address form like this. So int of float of 60 will convert 60 into float of type, and it will be stored into the temporary variable t1. Then t2 equal to id3 into t1. So that means first 60 has converted into float and stored in a temporary variable t1. Then that value will be multiplied with the identifier 3, that is rate, and this value will be stored into second temporary variable, that is t2. Then t3 will be the result, that is temporary variable 2 plus id2. Then the final temporary variable 3 will be stored into the identifier or variable position, that is id1. So this is the 3-address form of the given statement, position equal to initial plus star rate star 60. Now that particular intermediate code will be given as input to our synthesis phase. Synthesis phase is mainly consisting of code optimization and code generation. Code optimization means what? The particular 3-address form of our source program will be given as input to the code optimizer. Code optimizer means always we need an optimized code, right? Even though the programmer has written the program, whenever we are executing that program, actually that whatever program has written by the programmer won't be executing by the compiler. Instead of that, compiler will execute better version of our program if it can be. Okay, that means what if our program can be converted into, suppose our program is containing 10 steps. If you are able to convert this program with into containing of 8 steps, then we have optimized our code. Okay, so that will be performing in the code optimization phase of the compiler. So always whatever program we are giving to the compiler, directly it may not be executing by the compiler. compiler will check for the code betterment. If it can be, then it will be do the code optimization, then that better code, that means optimized code, will be executing by the compiler. So here these 4 steps has been converted into 2 steps. Okay, that means what was the first step in the intermediate code generation output? Int of float of 60, that means converting integer 60 into a type float. But here we are not performing the conversion, we are directly going to write 60.0. So there is no need of conversion, it is containing already fraction part, so there is no conversion. That 60 will be multiplied directly with the identifier 3, that means rate. Then that value will be stored into the first temporary variable t1, and that value will be added with the second identifier or the variable, that is initial, and that final result will be stored into the identifier, that is id1. So what happened? Actually we had 4 lines of code in the intermediate code generation output, but the compiler in the code optimization phase, it has been converted into, it has been reduced the code into 2 steps. So it is containing only 2 lines of code, so it is an optimized code. So the optimization will be performing in the code optimization phase, then that particular output will be given to the code generator. So in between this code optimization and code generation, actually we have one more stage, that is here in this particular system programming subject we will talk in detail about this storage assignment stage. That is, storage assignment is nothing but what all variables we have used in our program, we need to allocate space for those variables. That will be performing in the storage assignment stage. Then after that, that particular output will be given to the code generation. Code generation means what? According to the target machine, we have to convert our intermediate code or optimized code into the target code representation. What all registered names are there in the target machine, by using those physical real registered names, we have to write the code. Then we can execute that particular target machine code in the target architecture. These are the main 6 stages or phases of a compiler. Lexical analysis, it will break down our source program into stream of tokens, and the syntax analyzer will check whether this sequence of tokens are in correct order or not according to the syntax or grammar of the program, source program. Then it will given to the, and it will generate a parse tree. If we are able to create the parse tree, then means it is syntactically correct. Then that parse tree will given as the input to the semantic analyzer. It will check the meaning of the particular string. Semantic analyzer will check the meaning. If it wants to perform any automatic typecasting, it will perform there, and it will give the output to the intermediate code generation. Intermediate code generator will convert the source program into a 3 address form code. That means a single operator and 2 source operands and a 1 target operands. Then that code will be given as input to the code optimizer. Code optimizer will optimize the code if it can be. Then that optimized code will given to the actually storage assignment. Storage assignment stage will assign the locations to all the variables. After that, it will be given to the code generation phase. In the code generation phase, it will according to the actual translation will be done in accordance with the physical register numbers, okay, depending upon the target architecture. So it will convert into register names available in the target architecture, so that that code will be able to directly execute in the target architecture. So these are the main phases of the compiler. So in this particular system programming subject, we are going to see the main phases of the compiler as lexical analysis phase, syntax analysis phase, interpretation or semantic phase, then code optimization, storage assignment, and code generation. Okay, so intermediate code generation is also there, but here mainly we are concentrating on these 6 phases. In the next videos, we will be we will be studying each phases in detail. Thank you for listening.